Now something happened. Yeah. I don't see my slides though. Not really. Oh, there is. All right. Now we're live. Finally. Sorry about the delay. We had some technical issues. All right. My name is Klaus. I'm with Overs Copenhagen, and I want to tell you a little bit about our chapter before we start the talks. That's it. Oh yeah. Overs is a non-profit worldwide profit. So Overs is a worldwide non-profit non-profit foundation who aims to improve the security of software. And it's all non-profit, as I said, and there are a number of chapters around the world. We are one of them, and the goal of Overs is to make application security visible and teach everybody about application security risks. Everything is free, and also this talk. We're part of this Overs global non-for-profit thing, and there are 207 local chapters in 56 countries and counting. Overs has a lot of projects, so if you're into application security in some form, you should probably go and check one of them out, or more of them out. No, I guess no matter what you do, there are a project for you. In Denmark, we have 2 chapters, one in Aarhus and here in Copenhagen. And this is a picture of all our wonderful and beautiful volunteers. And we have always rooms for more volunteers. If you want to contribute to our chapter, you can do volunteer work. If you want to do a talk or workshop or something else, let us know. And you can also show up for events like these. That's also an excellent way to support us. You can follow us on Twitter, on YouTube, and join our meetup group to make sure you don't miss any events. If you have signed up for this, you are automatically added to the meetup group, so you'll be notified whenever we have a new thing going on. The plan for tonight. First, David from Day in Data will be talking about SIEM in general and Elastic as platform. Elastic will talk about Elastic SIEM, and in the end, Nabil from TheHive project will be talking about TheHive. There is 5 minutes of Q&A after each talk, and if you want to ask a question, do it in the YouTube channel, or in the YouTube chat associated with the stream. Yes, that's it, and over to David.
Cool. Let me just share my screen.
Yeah, oh yeah, I did.
You guys can see, right?
Yep.
Sweet, and then I'll just dunk my camera on. And you can see me as well.
Yep.
That's awesome.
Yeah, I'll just get rid of my camera then.
Cool. Okay. Awesome. Then I guess it's time for my talk finally. So yeah, I'm really glad that I was allowed to help set the agenda for tonight's Overs Copenhagen. I've been asking Klaus for a little while if I could help out by bringing a couple of my friends along with me, and I'm super glad that I could get both James and Nabil to say yes to tagging along as well. So there's some super cool talks coming up after my talk. Hopefully mine is quite interesting, but there's definitely some really cool guys coming on after me as well. So definitely hang around for that as well. But my talk, I wanted to start out this program kind of with an introduction to SIEM. So if anyone is sitting there who's been doing SIEM for a long time, this could be interesting for you, but this is much more of an introduction to SIEM. I will talk a little bit about data and about some of the problems that's there with modern SIEM technologies. But my main focus would be introducing people to SIEM who haven't seen it before, or who have just started out in it, or understanding, well, how do I use this platform for good? And that's kind of the basis of this talk. So just go into this. A tiny bit about me. This is me here, super young and fresh. Just when I first moved to Denmark, I found out that was like 6 years ago today, or not today, yesterday. I am British, as everyone can hear. I live in Denmark. I am the Cyber Defense Center department manager working at JN Data. I absolutely love open source stuff. I think it's the mindset behind it that I love the most. This whole attitude around sharing. It's the same thing that moves into cyber threat intelligence sharing, and it's just that whole mindset around. Okay, let's not keep this as our proprietary thing because this isn't where we're gaining money. Let's actually share this with community, and there's hope that they can also then bring value back to us, and by extending it, by doing more with it. It's this whole sharing mindset that I really love. I'm a blogger. I have my own blog with a couple of really cool friends as well, which is Security Distractions. And then I really love teaching, and I really love mentoring as well. I have my own mini internship that I do at JN Data, and I really love being part of helping out the Business Academy in Aarhus, and also doing some stuff with Aalborg University as well. And hopefully in April, I'm actually talking at Kia as well. So if anyone's here who's studying at Kia, I'll be there in April, I think, giving a guest lecture. So one of the things I had to mention here as well was actually a new project that I have been invited to be part of, and I'm really proud of this. This is just a quick side project around the SIEM kind of. It's not really SIEM, but it's talking about cyber threat intelligence, and some of the lackings that we have found in cyber threat intelligence, and why we believe that the cyber threat intelligence area is kind of failing a little bit in what it's supposed to deliver. Now, I'm really proud to be part of this project, and it's with a large number of heavy hitters in the industry. So some people that I really look up to have invited me to be part of this project, and I'm super happy about it. So I'll chuck these slides online afterwards, and you guys can go and check out this project. But I mean, the overall goal is to kind of, we're trying to improve the quality of how CTI is being used, and how cyber threat intelligence is being used, and also learn how and reinforce how we can measure the success of the CTI field, and measure the success of how we use cyber threat intelligence and how it should bring value to a business. A lot of us are tired of the current ways, and we really want to try something new. So people should definitely go and check this out. It's today is kind of the unofficial launch, but we have got a lot of things planned as part of this project as well. So that was just to name drop this. This is also an open source project, so it's well within the boundaries of the OWASP name. But let's get back onto some sort of subject here. So my plan today or tonight is to talk about SIEM. When I made this meme, I was super proud of myself because I actually thought it was hilarious, and I haven't stopped laughing about this all day. So I hope everyone appreciates this. But the goal of this talk is actually to give an introduction to SIEM. Firstly, talking about logging. So we're going to take a little bit of a detour and discuss logging first. We're going to use the lab that I've built for the Business Academy, which I call Saga Lab, to as an example for how SIEM could be built up and how logging is working. We're also going to talk about the importance of data and why data is so important to take responsibility of. We're going to talk a tiny bit about some of the problems with SIEM, and then we're also going to look at, okay, is there a possible solution to some of these problems that the industry is facing around SIEM? I'm hopefully going to fit all that into half an hour, so let's see if we can actually do that. I have a tendency to maybe go a tiny bit over time, but let's actually see. It's just because I have so much good stuff to say. So, as I said, we'll start out with talking about this Saga lab that we built at the Business Academy in Aarhus for students to play around with. Now, I don't expect everyone who's looking at this, and I know this is a SIEM introduction, I don't expect everyone to understand what they're looking at on the screen right now, but basically this is the lab that's been built at the Business Academy. Now, there are a lot of open source tools on here. There are some closed source stuff, like Windows 10 and the Windows Server. But the basis here is that what we wanted to build was kind of a mini organization so that students could actually understand, well, what is it like being in an organization when I come out afterwards? What kind of tools can I expect to play around with? What kind of things can I get my hands dirty with? And this was a pretty good representation of a number of organizations that are out there. And it also goes to highlight some of the problems that are actually inside the logging area around this. And we'll use this lab as a good example to show, okay, well, what is a log source and how should logs be shipped and what should we do about parsing and things like that. So I don't expect everyone to fully understand what's on the screen right now, but we're going to use this as an example for how we talk about logging. So let's start with logging. Now let's take an example. So let's say we've got that Windows 10 machine that we just saw inside the lab drawing. And let's say out on the internet it's going to access this totally legit.dk. And maybe there's some malware there. We don't know right now, but let's say that there is. So what's going to happen is it wants to do that. Well, a couple of things are going to happen. Now, it's not perfect how I'm going to describe this, but I'm going to describe it in this way anyway. So we're going to make a query to our DNS server, and we're running a Pi-hole here. So Pi-hole is going to be the one that's serving that. Pi-hole is going to say, hey, you know what? That totally legit.dk lives on this IP address. Then the Windows 10 machine is going to make the connection through the proxy server and say, hey, I want to go to totally legit.dk. So there are areas where we could already start doing logging, right? If you look at the Pi-hole, we had the ability to log the domain name. When we look at the proxy server here, which is a script proxy server, which is also open source, which is, we had the ability here to log the IP address and the domain name. And in the next one, which is the Pseudocode IDS, again, we had the same ability to be able to log the domain name and the IP address. Eventually, when we hit the pfSense, the firewall on the end, we could log the IP address again. So there are plenty of places, as this is going out towards the internet, that we can actually log this this traffic. So there are plenty of areas where event logs and logs are very, very important here. Now, when we actually try and map this into a logical mapping of exactly how is it that logs work behind this, how do we actually extract logs from these boxes, and what do we do with each log when it actually leaves these boxes? Now, some of you might have seen bits of this talk before because I've given certain bits of it at different events in the past, but I don't think I've given one that's actually been recorded, so I think I can get away with that. But these are the log sources that we're looking at as part of that diagram that we just gave, a part of that process that we just looked at. Now, these log sources, they end up, again, in this little box here called log sources. And what happens when we actually want to get those log sources to something? We want to basically extract those logs and we want to move them through a system so that then we can actually start looking at those logs. Now, of course, we could go out to each individual device and actually look at the raw event logs, but we really want these to not be on the individual boxes. We want them to be somewhere where we can centralize them. So we need to figure out, well, how do we get these log sources into something? And then how do we get them organized in a specific way that enables us to actually, look at them properly? So the first thing we do, and now some of you might have worked with logging before and say this isn't exactly perfect. Of course, it's not perfect. Like different logging technologies and different logging styles will be done slightly differently, but this is kind of my idea for basic logging architecture. So we need to ship our logs somewhere. Now, shipping could be something like Filebee if we talk about Elastic as a platform. It could be wow, my brain is completely lost on other shipping technologies. It could be many other shipping technologies. WinLogbee, which again is a kind of Elastic tool, but there could be many other shipping technologies that we'd actually use to get the logs off of these boxes. Syslog, Jesus, my brain lost. Yeah, Syslog could be a perfect one. But we need to ship the logs. Once we ship the logs, we then would like to normalize them. Now, what do I mean when I say normalize? When I say normalize, I mean make them kind of correlatable with other types of logs. Now, also, what does that mean? That basically means that we choose a schema that we're going to use that basically defines, okay, well, if this box logs a domain name, or every time that the proxy logs a domain name or the IDS logs a domain name, we need to give them the same name. And that will help us later down the line. And we'll actually look at this a little bit more later in the talk. But in normalization, that's what we do. We choose a schema and we do some mapping up against that schema. Then we can then, based on what we've done, then we can then begin to enrich the logs. We can enrich them with maybe threat intelligence if we want to. We could enrich them with doing DNS queries as we're doing logs. There's tons of really cool stuff that you can actually do to actually enrich the logs as they're moving through the process. You could do a GeoIP lookup as certain people do. You could do any number of things that you could do inside this enrichment area. Now, once you're finished with that, once you've kind of normalized and parsed and enriched your logs, you kind of have one last step or maybe a couple of other steps. But for me, one last step, which is, okay, well, I need to transport these logs now. So I need to figure out where am I going to then send them to afterwards. Then we land in some storage where, again, now if you're sitting here and you're working at Humio or if you're working at Splunk and you say, we don't index, okay, fine. That's not necessarily so important here. This is a basic logging architecture. Now, in this regard, we are looking at indexing as we do the storage, because it's then easier, from my opinion, to then build queries and visualizations over the top of that, because you can do them without having to index on search or anything else. You can actually just visualize and query data that's already been indexed. After you've actually done those queries and actually done some of those visualizations, then we can begin to talk about detection. So there's a huge process before we even reach this kind of detection area that has to go on before we can start doing detections. And I guess the point behind this slide, and actually try to reiterate this even early on in my talk, because my talk is kind of really going to try to be focused on asking organizations or asking you as a new SIEM person maybe to really try to take responsibility for the data that's underneath, because there's a huge amount of stuff that you've got to do before you can even write detections to make sure that the detections that you write are healthy. So there's a huge process that's got to be taken responsibility for before you can even do this. Now, that's a bit boring for anyone who's sitting there like, I just want to learn about SIEM, stop talking about logging. Okay, cool. So when we land the detection, then we start to begin to talk about SIEM. Now, you would have heard a lot of people talk about SIEM. A lot of organizations believe that SIEM is a magic bullet that's going to solve all of their problems. Now, yes, SIEM can solve a lot of organizations' problems, but it can also introduce a whole lot of new ones if you don't take responsibility for what you're actually doing with it, if you don't take a lot of responsibility for the actual data underneath. Now, this is an issue that's definitely faced inside in the industry, and we'll talk about that a little bit later, some of the problems that there are with SIEM. But if we want to take a definition of what SIEM actually is, now, I chose the Gartner definition of this, and I don't know how many people are sitting there thinking, God, he's talking about Gartner, but actually, you know what? I looked for a good definition of SIEM, and I thought, should I write my own? And I was like, you know what? Gartner probably have a pretty good one, so I kind of borrowed theirs. The idea of SIEM is basically, and I'll just won't read the whole thing, but essentially, it's this need to analyze event data in real time, to build detections, not necessarily against targeted attacks, because that's not quite right, but to detect data breaches. Then also to work to collect and store, and then investigate the logs that you're actually you're collecting for the use of incident response, to do forensics, and of course you can't forget that last one, which is what a lot of organizations buy SIEM platforms for, and that is to achieve regulatory compliance. That word was too long, but that was to achieve regulatory compliance. And essentially, SIEM technology aggregates event data produced by many different sources, and the idea should be that it should also correlate, or at least there should be some form of correlation going on inside your SIEM, or even pre-SIEM, when you're actually taking responsibility for your logs that enable you to use SIEM more efficiently. Yeah, it was borrowed from Gartner, and I tried to reference them there so I don't get any legal trouble. Thanks, Gartner. Cool. So I hope you're sitting there with a sense that you understand SIEM now. So that's awesome. I guess my talk is finished here. But for those of you that don't quite get it yet, let's actually focus a little bit more. So if we go back to that drawing that we had earlier, and we look at all these different areas where we had this totally legit.dk, where we had options to be able to log. Well, if we talk about a pseudo alert, just basically pseudocode, where we actually say, well, actually, no, I just want to build an alert on www.totallylegit.dk. Someone's told me that that's a bad domain, so I just want to build an alert on it. Well, cool. That's actually the basics of SIEM. It's building alerts based on data that's actually there. Cool. So let's build an alert based on totallylegit.dk. Cool. Well, that's what we could do in a pseudo sense. Well, that's a really basic description of what a SIEM is. Now, there's a whole lot more to it, of course, but maybe let's also first start taking some more responsibility for the data. And I hope that you guys are kind of sitting there thinking, okay, he's trying to hammer this home that taking responsibility is kind of the key to SIEM. You know, understanding your data, owning your data, being able to completely take ownership of each log source that comes in and how it's parsed and everything else. That's the key behind all of this stuff. But if we look at something basic at the start and we look at those log sources that we had the potential to deal with, so we had a Squid proxy server in there. There we go. We had a Squid proxy server in there. We had Pseudocode, which was our IDS platform. And we had a Pi-hole, which was our DNS platform. Now, there were 3 different places that we could have actually logged this www.tolegit.tk. Now, if we want to build an alert on these already, if we don't take responsibility for our data, what's going to happen? Well, if we don't take responsibility somewhere for this data, when we want to build an alert on tolegit.tk and actually build a pattern that actually matches, we're going to have to take account for the fact that the Squid proxy server is logging it based as cs.host or cs_underscore host. It's also then in the Pseudocode engine, it's logging it as hostname. In the Pi-hole, it's logging it as domain. That means essentially that we're actually going to have to build 3 SIEM rules, because when you're building SIEM rules, you're building them based on something equals tolegit.tk. So you're going to have to take account for this. Now, if you're not careful, you can end up having to build 3 SIEM rules to do this. And this is then where, again, like I said, taking responsibility for your data becomes super important. Understanding the data and actually taking responsibility for it. Now, when we meet in the middle of all these 3, what do they all have in common? And we choose our schema. What can we then do with a schema? Well, we could choose something that they all have in common, which is basically, well, that was a destination domain. So if they all were mapped into the same type of schema and all delivered the same type of data in the exact same way, all of a sudden you have this, harmony around destination.domain. So once these have all been mapped into that schema, all of a sudden you don't need to create 3 rules. You can just create 1 rule, and then you can point it at all the log sources at the same time, because you've actually got this destination.domain. And you've taken responsibility somewhere, you've chosen a schema that actually matches what you want to do. Now, there are going to be people who are sitting there and saying, well, that's not how Splunk works, that's not how this tool works. Yeah, but that's totally fine. You can let Splunk, or you can let whatever other tool there is out there dictate to you how your data should look. Now, that is what a lot of people will say, that, okay, well, my platform takes responsibility for the data itself. Cool, let it do that. The problem then comes, have a basic incident response process, just a very, very simple one. You have stage 1 where you have an alert coming in. Stage 3 is supposed to be stage 2, so I have shortened this process a little bit and I have forgotten to fix the numbers. That's actually quite embarrassing. But basically, stage 2 was in there somewhere, but stage 3 is where you do analysis. Stage 4, you do some response, and the stage 5, you do some reporting. Now, if we think SIEM detections, they are only actually part of stage 1 of an incident response process. Now, if you as an organization are going to allow your SIEM platform or the tool that you buy or the vendor that you jump in with to dictate how your data is going to look, well, you're only allowing them to take responsibility for that first part. You're only enforcing that data from the first part. You've got a whole road to go through before you can get to reporting, where you have to take responsibility for the data that then comes in afterwards. Now, if we look at fast tracking this alert, what started with to what it could have ended with at the end. Now, if you actually look at this, we had an alert that went off that said that destination.domain tolegit.tk, that was part of a SOC alert, SOC 03, and it was incident type malware. When we actually did some analysis and did some investigation, look at how much we expanded this data. Now, my point here is to basically say that why would you let stage 1 dictate how your data should look? Why shouldn't you let your stage 5, how you actually want to do reporting, dictate how your alert should look? Now, this is my point here, is basically saying you as an organization, or you as a SIEM guy or a logging guy, you really need to look at this as a whole, a whole life cycle, where you really should actually start at the end and actually describe, well, how is it that I actually want the output to actually look first before I decide, well, how is this vendor going to tell me how it's supposed to look? No, you should tell how it's supposed to look. It's your reporting at the end. It's your data at the end of the day. You shouldn't be listening to how another vendor wants it to look. It's yours, so you decide that. I hope that I kind of hammered that home a tiny bit. Maybe I hammer it home a little bit too hard, but again, the point here is kind of, why would you let stage 1 dictate how stage 5 looks? Why wouldn't you let stage 5 dictate how stage 1 looks? That's kind of my point here. Now, again, there are a couple of problems, at least even in this world. If we're only looking at things like building alerts on just domain names or on IP address or on anything else, over time, our alert catalog or our SIEM catalog, our detection catalog might end up just looking like this, where we just keep going on and on and on with domain names or IP addresses. When does it stop? Also, we all know, well, a lot of us in the industry know that a domain name or an IP address only has value in a cyber attack for a specific amount of time. You know, these domain names, they get recycled, they get brought down, they get taken down, and then they're not there anymore. Yet we will still be searching for them in our SIEM platform. So we need to look at something that will actually give us some sort of dynamic or allow us to actually lifecycle this. Now, I'm going to quickly focus on a tool that I actually built quite a long time ago with a colleague. But this is not just a tool that we've built, but this is also Elastic does this, Splunk does this. Everyone has a way of actually building this a bit more dynamically. Now, if we go back to what we said before about all of these logging and actually taking responsibility for the data and forcing them all to log destination.domain, then we've got a very fast way of actually mapping them all into some sort of enrichment, where we can enrich them with Elasticsearch, which is a tool that I built, but it could be any other way of doing this. And essentially inside Elasticsearch, we have a MISP platform that's holding a list of these indicators, and it's dynamic, right? These are actually being life cycled. They go in there for a period of time, and then they go out. But we all know that if we actually link up against this, that way we won't end up with this huge alert catalog that's just overflowing with old domain names that have absolutely no value. If we actually hand this over to something else that can handle them a bit more dynamically, that's actually really, really great. So what happens here is that we end up in enrichment. We can then ask Elasticsearch to go and actually look up something like tolegit.dk. We can send it back to the enrichment engine, which will then add an additional log field, something like misp.hit equals yes, and then we can build a detection on that. So there we go. It's a bit more dynamic SIEM, a bit more dynamic indicator-based SIEM. Now, that's cool. But so far, we've only really talked about indicators. We've only really talked about things like domain names or IP addresses. If that's all you're doing with SIEM, you're going to have a pretty hard time because these indicators, these domain names, they only come up after someone has actually detected an attack somewhere else. You maybe get them from a threat feed provider. You maybe get them from wherever you get them from a peer who you peer with via MISP who sends you these in. Cool, but again, they're all based on things that have already happened. So how do you detect something that's happening to you in real time that hasn't already been detected by someone else? We need to move our focus away from basically being indicator driven to looking at something else. Now, there's definitely something missing in the current setup. So if we actually look at it and say, okay, now I don't expect everyone to understand this straight away and get it. So my slides are going online if you want to dig back through them. We have this pyramid that we call the pyramid of pain when we're looking at SIEM or we're looking at cyber threat intelligence, and they basically say that an attacker they have this pyramid of pain, and it's defined based on, well, how much pain does it cost an attacker to actually be able to change some of these things. So if we start at the bottom and look at hash values or IP addresses or domain names, even those three are relatively easy for an attacker to move around to. So just because you know about an attacker using one specific domain name and you actually catch them using it, it's very easy for them to just shift to another domain name and then reestablish a connection and carry on without you ever knowing about it. Where we aim to achieve, which is kind of the gold standard, is this top area. Now, TTPs is essentially where we're looking at more behavioral-based detection. We're looking for the attacker's actual behavior, things that they're inherent to them, things that they maybe can't change. Maybe they're used to using PowerShell, and an attacker is only understands PowerShell. Cool. Well, if they're really used to using PowerShell and maybe some other behaviors alongside that, and they can't change them, well, then let's really go after PowerShell. If we know that guy is targeting us, let's really first put our focus on detections in PowerShell. And that would actually force an attacker to then, if they had to change, they would maybe actually just change the organization they were targeting rather than targeting you. Now, how do we actually do that? How do we actually bring this behavior into SIEM and into our detections? Well, here we have this really cool framework called MITRE ATT&CK. Now, MITRE ATT&CK, which is up on the screen right now, has been through so many iterations that actually it's not actually very easy to show it in a very nice graphical form. They used to have a really cool graphic, and I was actually looking for that graphic before I came on, but they've kind of modeled it up a little bit by adding in all of these subcategories and all these other stuff. And again, I don't expect you guys to understand it straight away or anything like that, but the basis for MITRE ATT&CK is that MITRE ATT&CK is basically built up of attackers' behaviors, starting with things like reconnaissance. Now, this is the new version. They've added in pre-attack and post-attack, and they've combined them all together to make this one big thing. But my old version of MITRE ATT&CK was basically starting with things like initial access, where how does an attacker actually get into an organization? They'll use maybe phishing. Now, phishing can be broken down into a couple of ways of doing phishing. You know, are they sending in an attachment, or are they doing it just via a link? Now, you might be sitting there thinking, this sounds really basic. Well, yeah, it does sound a little bit funky, but at the same time, attackers will struggle to shift that behavior. If they're really used to using spear phishing links because they use a specific platform to host them on, then yeah, it's really hard for them to move away from that. And MITRE ATT&CK is basically based on defining a lot of these behaviors. Now, we're going to look at one very, very simple one quickly, and I'm not sure how I'm doing for time. I think I'm pushing it, but let's see. And look at a behavioral rule really quickly. If we look at something like bits admin and make a pseudo rule about this, where we actually look at bits is used as a transfer protocol on Windows, and a lot of attackers tend to try and lean up against it because it's something that defenders like us, a blue team, they don't really look for very often because they're more used to looking at HTTP, HTTPS requests. They don't really look at this bits.admin working. Now, a pseudo rule here could be to build a detection on this type of behavior. And as you can see here, we're not really looking at indicators anymore. We're not looking for domain names or IP addresses. What we're actually looking for is building an alert based on when bits.admin starts up, and if also the command line parameters are */transfer*, then we would like to build an alert. Now, I stole this from the Sigma repository. If anyone knows that, I've put a link in the talk as well, so you guys can have a look at that. But that would be a basic behavioral detection rule based on an actual attacker's known behavior. Rather than looking at, like I said, an actual indicator, this is actually bringing it back to an actual behavioral style detection. Cool, it all sounds really, really cool, right? But again, there's issues with this. And the very much bigger problem in this area is actually that when you want to start bringing in things like MITRE ATT&CK, you also need to have an understanding of an attacker's behavior. And that means that you need to bring CTI in. That means that you need to bring cyber threat intelligence into the picture. And that takes time and that takes effort. And it's not a magic bullet at all. You need to really, really invest time into understanding what your threat landscape looks like. Again, a lot of organizations try, or at least think, that they need to get 100% coverage on the MITRE ATT&CK framework. They think that that's exactly what they need to go for if they're ever going to be successful. And that's also not the case. If you have the money, then of course, go after this. But MITRE ATT&CK is not really built to achieve 100% detection rate either. You really should set your detection coverage to be based on your own threats. What's your own threat landscape? Now, this actually requires an organization to actually take responsibility for that. Again, we come back to this data thing. We come back to this whole taking responsibility for understanding, well, what threats do I actually face? If I'm going to buy this huge SIEM platform that's going to cost this much money, maybe I really should take a step back and actually first understand what the threat landscape is that I'm living in. So if your organization is in the healthcare industry, well, maybe you should try to focus on threats targeting the healthcare industry first. Have an understanding about that. Work with some of your peers as well. This isn't to say that you should be on your own. But again, most organizations are still failing at this. There was a really cool post that was put out 2 days ago on this link here, and you guys can go and have a look at it, that basically says that only 12% of organizations are actually achieving any type of MITRE attack coverage. And it's a really, really interesting article that I would highly suggest that people read if they're interested in this area, because again, it kind of shows that how difficult it is to actually get a SIEM and take responsibility for that data. One possible solution, I'm not saying this is the perfect solution at all, but a solution that could come in the future and could help in the future a lot, and I already see the value of this working in the industry that I work in, is well, if it's so hard for one organization to understand their own threat landscape, but they still believe that they need a SIEM, why can't organizations actually end up with some sort of shared catalog of detections? Rather than go and pay some cybersecurity vendor to give you a huge catalog where they don't really understand the threat landscape that you're specifically facing, why not go and go to your cert? Now, I'm not saying that this is a perfect world, because there are not certs in every single industry area. It would be super cool if there was. This is why I put this as a possible solution to solve this problem. In the critical industry areas, there are a few of them coming up. So why not give this responsibility over to that central cert and say, well, you could understand the threat landscape for us, because maybe that's where we should put our energy into, having you guys understand it. Have you guys have the CTI, and then give that detection catalog to them, because maybe they're the experts. Now, I've been working with a super great intern on this project from the Business Academy, who I recently hired at JN Data, and his project actually is built on that exact premise. Now, maybe if you can't see this drawing perfectly because of the stream quality, that's a little bit crap, but these slides will go out afterwards to give a very brief description of what this is. What we're saying is that a central cert body, which would be at the top, would essentially host most of the detection signatures. They would host most of the detection rules, and they would simply then exchange those detection rules with organization A and organization B. They would essentially send those rules into organization A's MISP and organization B's MISP, where they would be storing threat intelligence or anything else. They'd basically be using this MISP platform as a database for detections. Rather than using it just for CTI, they could also use it for detections. There'd then be a little piece of code that queries that engine and actually translates the generic detection language into whatever SIEM platform that organization A or organization B has collected. So essentially, it wouldn't really matter if organization A was running Splunk and organization B was running Elastic, because this would end up being completely agnostic. It wouldn't really matter. Neither organization would have to worry about what the other one was using. They would give this over to the central cert, and the central cert wouldn't really have to care either about what that was using. Now, we have done some tests for this, and we've actually made a proof that this actually works. In case anyone's sitting there like, you're dreaming. The proof works. Now it's just a question of convincing people to actually go down this path, which is a very long road. But hopefully, Mikkel is going to release a video and his and some of his script and the platform at some point soon. So if anyone would like to start playing around with it, you can actually build this inside your own lab as well. Cool. So, good news, everyone. This is my last slide, and I think I'm just on time. I think my closing comments are: working with SIEM, in case I've put you off, I hope I haven't, but it's a very, very exciting area to be part of. It's providing that you then take responsibility for the data that's actually flowing through your SIEM, providing that you understand that this is a constant process. This isn't something that you just buy and put into action and say, well, cool, my vendor's giving me 50 detection rules, my vendor's giving me 100 detection rules. Yeah, cool, but do they actually work for you? Are they actually relevant for you? That's the key here, is taking responsibility again, understanding, right, well, these rules are giving me that they're okay, but I need to add another 100 if I'm going to make this work, or I need to add another 10 because my threat landscape is so small that I don't need to worry about all of that stuff. I only need 10 of these. Maybe that's probably not the best solution, but maybe you have that threat landscape. Combine it with cyber threat intelligence to ensure it's doing its job, and then make sure that you have threat landscape map detections. Now, it could be indicators. Again, indicators, there's no harm in using them. They have a value, but they definitely don't have as much value as building behavioral-based detections. So that was the end of my talk. I hope that was valuable for people out there. I guess my last closing comment is, again, like I said, you really have to take some responsibility for data when you're working in this area. So cool. Thank you everyone for listening. I know I talk fast, so.
That's okay. We have a few questions if that's okay.
Cool, go ahead.
We have a question from Mario Hobel asking where we can get this dynamic threat intelligence information for domains and IPs. Is it open source or commercial?
I guess the answer is a bit of both, actually. If you pair up with a number of other organizations, you can actually, one of the first things that you can actually do is go and download and set up a MISP, where I've done some talks about MISP in the past. There's a lot of cool information out there about MISP, and actually you can join up to the public feed that MISP gives. There's a public feed that's run via the company that actually is behind MISP, where they have a public feed that they're sharing data into. You could also join up to the if you're working within Denmark, you could join up to the Danish MISP, which is run by one of my close friends, where he's also then resharing organizations' intelligence. There's a really, really large sharing community around all of this. So yeah, there's a lot of open source intelligence out there if you actually know where to look and go and pick it up. There are also a lot of really cool vendors who are sharing this information, but I would always fall back to the open source sharing setup.
Yeah. We have a few more. What do you see as the common mistakes that people and organizations are doing with the SIEM? And also as a follow-up to this, is there anybody out there who can actually truly successful, except of course for your own company? But
I guess the first one would be to answer the first one. Some of the mistakes that are made are that whole thing I talked about on this last slide here, was the whole purchasing a SIEM platform, getting 50 rules that come out the box and basically saying, okay, that's great. Or buying a SIEM platform just to be compliant and just leaving it. If that's your main goal, then that's totally cool. But I would think that's probably a bit of a disappointment to what that platform could actually do for you if you actually set into it and set some time aside to run it. Now, I know I'm talking from some sort of dream world where I say you need time to be able to do these things, but yes, you do. If you want to do it properly, yes, you do. You definitely need to put time aside to do it. So I guess what some of the common pitfalls are a lack of understanding from the organization to what SIEM is actually supposed to do. And that could be a failure from the blue team side to not being able to describe it. There could also be a failure from the security sales side out there on that they have to make a sale, right? So they have to sell this platform and they have to make it look really sexy, because what they think management people want is hundreds of rules, when actually what you really need is maybe fewer, more quality rules. So those are the pitfalls. And do I believe that any organization is getting it right? I believe some people have the right way and the right attitude towards getting it right. But if you actually go back to that article that I posted, there are very few that get it right and that get it 100% right. That's why you then have to bring in other things like EDR, other detection platforms that can maybe help you along the side. Now, I would also always map those into my SIEM, but the power of also then bringing in other log sources which have a lot more quality can also enable your SIEM to be better. So I guess my answer to that last one are that there are very few that get it right, because there are very few that actually understand it. And then not just understand it, but then also enforce that they need the time to actually work with it.
Yeah, it's complex. That's my understanding as well. And also, I mean, there's a lot of fuss going on with the different definitions of things like threat hunting and threat intelligence and all that stuff. I mean, it's a bit muddled or unclear or whatever.
Yeah, and I mean that's actually that slide that I put up earlier about the antithesis project that I'm part of. That's actually one of the reasons why we set up that program, is because we're super frustrated with the industry, where we believe that we're failing ourselves in the industry at being able to describe this properly. We believe that we're being driven by the wrong things. We really want to try and make a difference. So that's me plugging my new open source thing, which is with these guys, which I'll put this slide up afterwards. You guys can go and have a look at it. But that's kind of our rebellious part of this, where we're rebelling against the industry that we're part of and saying, well, why do we have all these definitions? Why have we not taken any responsibility for this in the first place? Why are we letting others take responsibility for this for us? So,
that's very interesting. We we hope you'll talk about it later whenever you have your product started up. Probably that sounds very interesting. And the last question I have is also from a speaker. Oh, sorry, from a viewer, Kristen, who wants to know how we can get his hands on your Saga Lab.
Yeah, that actually is a very good question. You can't get your hands on the actual Sega Lab because that's the one that's running inside the Business Academy and is for the Business Academy students. But what you can get your hands on is that I'm running a workshop, not this Saturday, but the Saturday afterwards, where I'm actually going to be opening up my own lab for people to play around with, which is running Elasticsearch, which is basically the Sega Lab, but a mini version of it, running at home on my little tiny Nook here with 64 gig of RAM. So let's hope that it holds out. I'm fairly certain it will. But I'm running a small setup like that, and I do plan on at some point on completely open sourcing the entire thing. I just have not had time to put any of the code online or anything else because it is a huge setup. And it's not a huge setup in the fact that it's not that huge to build. It's a huge setup to actually then, like I said, to take responsibility for the data inside there, because even though it's a lab, I've had to take responsibility for all the data flowing from every single source, map it into everything. It takes time. Yeah. And then to open source that also takes time. So it's coming if anyone wants it for their own lab. But like I said, there's a workshop next week run via the OWASP initiative that there's a meetup for it as well.
Yeah, and you also had a baby recently, and congratulations with that. And you also need sleep, right?
Yeah, there's also that part of it, right? I actually only finished this talk like this afternoon as well because I've been so tired. So I'm sure that having 3 kids was the healthiest thing for my cybersecurity habit, but let's see.
Probably not. Well, thanks a lot, David.
No problem, and I hope you guys enjoy the next talks as well, because they are some of the coolest people in the industry coming up next as well. So.
Yep.
Cheers, everyone.
Yes, and we'll hand the microphone over to James.
Perfect. Thanks, Klaus. Hi, everyone. My name is James. I'm just about to share my screen very quickly. Can people see? I'm still David. I think you need to stop sharing yours. There we go. Awesome. Okay, turn on my camera. There we go. All right. Good evening, everyone. Thank you for joining at this late hour. I know everyone's very overwhelmed with virtual conferences and that thing, so we do appreciate everyone joining. Just a bit about me. So obviously, I'm the Elastic guy, so I'll be talking a bit about Elastic, but I'll just introduce myself very quickly. So I've been doing defensive side of security for about 11 years now. So anything from blue teaming to detection engineering to creating SOCs, running my own company for a while, sort of like a managed security service provider on Elastic. So I've been doing that a long time, literally my whole life. Everything David talked about, I know all those struggles. I've seen all those struggles. And it's sort of led me to where I am today. So just about 2.5 years ago, I joined Elastic as a security specialist, basically helping our users and our customers deploy Elastic for the same reasons David was describing. Just because I had all that in-depth experience, Elastic started to invest more in the security side of things. And I was the first person outside of the US actually to start doing that. So I've had the opportunity to travel the globe, not last year, but the years before that. I've literally been every place you can think of, talking about the goodness there. I recently switched over to the marketing team though. So because one of my biggest passions, apart from being technological and doing things with my hands and that sort of stuff, is I love making people get excited about new technology, Elastic being one of them. So like if I can end this talk with people feeling that they can go to a new type of product and try something new and be excited about it, that's sort of what I really enjoy doing. So I switched over to marketing just at the end of last year. Shameless plug as well. So once David did it, I'll do it. I recently launched a website called witchfish.com, which is basically an initiative to make something called certificate transparency logs useful. So it's completely free. You can go use it. There's an API for it as well. So if anyone wants to check that out, go ahead. I do live in Malta. I'm Maltese. For those of you who don't know where that is, it's a tiny island in the Mediterranean. Not nowhere as nice as Denmark, right? So just say that. But if you enjoy the sun and the beach, it's probably the place to be. Something that's not security or work related, I love progressive metal. So for those of you listening to bands like Periphery and modern bands like Tesseract and some others, that's what I listen to and play as well. So I am a musician, as you can see with the guitars behind me. Love The Office. It's the best show on the planet. Your opinion doesn't count on this. It is the best show. And as you can see from my miserable attempt at a tulip there, I love coffee, making coffee, and also I have a cat who, ironically, his name is Mouse, and he's right there behind me if you can see on the camera. But that's just a bit about me. Let's start talking about Elastic now. All right, so what is Elastic? Some of you might be on this call who have never heard of it before, or maybe you've been using it for a long time. And most of you might be using Elastic every single day outside of the security space, because Elastic is one of the most popular open source search engines there is. So if you use things like Uber, that's completely powered by Elasticsearch. If you use things like Yelp or any of the more common apps these days that have search, it's probably running Elasticsearch. And you're basically, it's there to search for anything. How's that relevant to security? Well, as David was just talking about, right? We're looking for things. We're looking for bad domains. We're looking for bad hashes. We're looking for TTPs. And I always say that when we're doing security analytics, we basically need to have an urgent conversation with our data. That's basically what it boils down to, right? We need to know about something, either as it's happening or as it's happened. And Elasticsearch allows us to do that because it is a security as a search problem. And there are many, many uses for Elasticsearch, right? So, and we sort of focus on three main areas. One of them, of course, being security, and sort of one of our main pillars. We have this other thing called observability. So things like infrastructure logging, application performance monitoring, server uptime, that sort of stuff. And then, of course, we have search. More recently, we have something called enterprise search as well, which is essentially like a centralized search platform for things like Google Drive and G Suite and Box and Confluence and things like that. So you put them all in one place and search them from a unified location. What does the technology look like? I'll go through this quite quickly because we don't have too much time. But essentially, we have all those three solutions at the top, and then we have the Elastic Stack. Elastic is an open-coded product, so it is free for anyone to use for as long as they like, and all the code is open. We do have a commercial side to the product. I'm not going to talk about that much today at all, but even that is open-coded, so you can just go and see everything that we do. We don't believe in security through obscurity. And I'll very quickly go through the stack itself. So at the heart of everything, there is, of course, Elasticsearch, which is the main data store, and that's where all your data sits, right? So if as David was saying, you have things like domains, IP addresses, logs from your proxy, logs from your host, EDR logs, wherever. You chuck all the data inside of Elasticsearch. And Elasticsearch was designed with scale in mind. So it scales horizontally. You typically don't really think about it too much. You do need to plan, of course, but it takes care of a lot of the traditional problems that we tend to have with scale. We need a way to get data in. So David already mentioned a few of these, like our beats, which are essentially data shippers that you can install on pretty much anything with an operating system. Or we have things like Logstash, which is more like a Swiss Army knife, because you can essentially do whatever you want with data. You can bring any data in, transform it in any way, and send it anywhere you want. That's literally Logstash. In fact, you'll see Logstash come up with some other security vendors as well, because it's an open product. You'll see recommendations for its use in things like Azure Sentinel and even Google Cloud Security. They all recommend using Logstash in some way or another. And lastly, we have Kibana, right? So as a security analyst, if I need to write those detection rules that David was saying, or if I want to look at the results, I need a user interface, and that's Kibana. Kibana is going to take care of all the front end for you. And 99% of the time, you're going to live within Kibana. The other things, if they're set up properly, you don't really need to touch them. That being said, Elasticsearch as a data store can be run with any front end. So you're going to see Nabil talk about TheHive. TheHive has the option to run with Elasticsearch's backend. Obviously, that's not fronted with Kibana. So you can write your own UIs on top of Elasticsearch if you want. That is totally up to you. And you can deploy Elastic anywhere. That's really important. So there's no limitation there. So you can run it on-prem, like David's going to do in his house for his workshop. You can run it on bare metal, Docker, Kubernetes. We have our own Kubernetes operator. We do have a full SaaS service for those who don't want to do that. But the choice is yours, right? There's literally any option you can think of, you can run Elasticsearch that way. Moving on, and it all really boils down to three things. Why did people even dare start using Elasticsearch if it was built for search? Why did they start using it for security? And it's many of the reasons David already mentioned, right? Today, more than ever, we need something that's fast. And Elasticsearch solves that problem. Because if you're waiting more than a few seconds in Elasticsearch, it's typically a problem. You shouldn't be waiting long. It scales with the needs of today. So we're not talking terabytes these days is absolutely normal. Talking petabytes is also normal as well in certain situations. So Elasticsearch is built for that kind of data. And then you need relevant results. And this is the classic, what do you mean by relevant results? If I search for, this is legitdomain.com or .dk, I want to make sure I'm getting results that are related to that domain. I don't want to get results about microwaves. So this is, Google versus Bing. Google gives you relevant results. Bing, not so much. Okay, if there are any Bing fans, well, if that's your thing, that's up to you. But that's what we mean by relevance. We already spoke about these, but the one I do want to mention that's sort of at the bottom is, again, I'm not going to talk about, we're not going to go into the commercial side, but if anyone did ever enter a commercial relationship with Elastic, we have a very simple model than most. So you basically pay for the compute resources you need to run it. We don't care how many gigs per day you have. We're not going to penalize you for putting more data inside of your platform. That's not the way we work. We don't believe in that sort of model. So just to point that out. Switching gears into security, right? So we've been on a bit of a journey. So it hasn't always been about security at Elastic. You saw on my intro slide, I've been using it for close to 9 years. So that's literally when it came out the first time. Just a bit of context. Elasticsearch was initially created by our current CEO and founder, Shai Bannon. He initially started to create a recipe search book for his wife, who had started to learn how to become a chef. And she had no way to search her recipes. And he's like, hold my beer, I'll build you something. That ended up being Elasticsearch. And that was way back in 2010. So we've been on a long journey ever since. So with onboarding tools like Logstash and Kibana, which were other open source projects, and we just incorporated them into our stack. We saw the use of Elasticsearch growing as what we call a threat hunting platform more than a SIEM. So initially, Elastic was just used to offload all that typically very expensive data to house inside the platform, because either my existing SIEM technology couldn't keep up, or it was just too expensive to do. So people would just offload some of that data into Elastic to search it. But then over time, we started to realize how effective Elastic was for security. So we made various different acquisitions. We joined forces with several different security companies, and we are where we're at today, which is an open, free security solution. Call it a SIEM, call it whatever you want, which also has endpoint security for free as well. And we'll see that in as part of the demo as well. Talking a bit about the current state of security. So again, David mentioned a bit of this, but getting harder and harder. It's not getting any easier, right? Especially as attackers become more motivated. They need to find more sophisticated ways to get what they're after. It's going to get harder to detect. Querying and looking at your firewall logs or just one source of data, it's not going to get you anywhere, right? And that's sort of the current state of the land, which some of the things we're trying to solve at Elastic is these problems that you see on the screen. I'm sure some of you have seen slides like this, right? This is also a huge problem. There's so many different types of technologies, so many vendors, and every time I see slides like this is the only thing I can think of. Like, that's the face I make, because I think it's just ridiculous. And that's sort of one of the problems we're also trying to solve, is that tooling consolidation. Like, you shouldn't have to have so many tools to get the security job done. And so that's sort of another thing we're trying to do, is really narrow down the vast tool landscape. You're free to use whatever the heck you want, right? So as David said, use whatever you need. Use whatever you're gonna use to get the job done. It's your data. It's your techniques. It's your infrastructure. Whatever tool you prefer using, use it. But we're trying to bridge that gap. We're trying to offer sort of a combined solution to narrow that down a bit. And we have these are our main this is like our mission statement for security. We want to sort of really eliminate any blind spots. So if you think of a data set that you want to collect to give you better visibility, to give you better MITRE ATT&CK coverage, whatever it may be, bring it in. Don't feel like, oh, I can't because of a cost or whatever. With Elastic, you're not going to pay like more license or anything like that. As an open product, we're going to eliminate that for you. And the platform will scale as well. So you don't have to worry about the platform not keeping up. And that ties into the stopping threats at scale. So like, again, threats across every type of data you can think of. It's there, you can do it, whether that's cloud data, whether that's I don't know, GitHub events, whatever you want, bring it in, it's going to scale. And the last one is very important. Arm every analyst. What do we mean by this? Like, we don't want someone to have years of experience of detecting threats or being a blue teamer to use Elastic. We want someone who's just starting in the industry to be able to do it as well. It's tough enough as it is. Like, we don't want to have to create something that's, oh, I can only do it if I have this super expensive certification. Or no, we want anyone to be able to do it. And we're going to see in the demo, which I'm going to switch to in just a sec, but we're at version 7 of 11 of the stack now, and this is sort of where we're at in terms of the security operations workflows that you can do. So this is all available right now. So you can literally go and download this today, and you'll have this workflow. It's not as plain Jane as that. As David said, you do have to prepare your data. You do have to make sure it conforms to a schema. So we have our ECS as an example, but you can do all of this in Elastic already. If you were watching this talk 2 years ago, none of this existed. None of it. Even a year and a half ago, half of the stuff didn't exist. So we officially launched our first security product in June 2019. So we're here now from that date, which is pretty exciting. I'm not going to go through every single step, but we'll see some of these throughout the demo. I will talk about a few other things which are not necessarily Elastic security related, but they are Elastic Stack related, which are very relevant for security. Hopefully this video comes through well on the stream. I doubt it, but there's two main things I want to talk about. One is this concept of searchable snapshots. So one of the biggest headaches we've had is I have tons of data, but after a while, it's just too expensive to keep on physical hardware. Not because Elastic's expensive, but the hardware to house petabytes of data it's too much, right? Or even like to have racks and racks of just storage is too much. So what we've introduced is this concept of being able to archive data in somewhere really cheap, like an Amazon S3 bucket or any cloud bucket or any cheap storage you can think of, as part of a snapshot, but still be able to search it. And that's coming very soon. So we introduced the first phase of this with our code tier. The rest of it is coming very shortly as well, sort of the full frozen ability, as we say, to do this search. Moving on. Can everyone see my stream? Because I see myself frozen. I'm not sure if I'm still streaming properly.
Yeah, we can see you. No problem.
Oh, perfect. Okay. There was one other thing on the previous slide, which is something we're calling runtime fields. Runtime fields is essentially the ability to manipulate your data in Elasticsearch after you've brought it in. So this is, as David was saying, to prepare your data from before. I'll just go back to it. It's quite hard. Like, there's a lot of process involved, and sometimes things do slip. Sometimes things do fall through the gap. You might forget something. There might be a bit of data you want to adjust after it's brought into Elastic. And that typically was a bit of a headache to do before, right? We believe in this concept of what we call schema on read, which David said indexing, which is basically indexing on write, I should say, not on read, which that means as the data hits Elastic, it's indexed, ready to go, very easy to search. That's very performant, very powerful, but it's good to have the flexibility of schema on read as well. So the ability to manipulate data after the fact. And that's something we introduced in 7.11. So it's a stack feature, but very relevant for security. We have multiple blog posts on these, so if you're interested in learning more, do go read them. But I did want to make you aware. One more slide before hitting demo. So I just want to highlight this sort of maturity curve for anyone who's sort of looking to see, okay, what's more of the step-by-step of how mature I am in my detection strategy or what I do, my analysis. So like David's step 1, 3, 4, 5. This is sort of what it looks like. And now we're in a position at Elastic where we can cover most of this. So whether that's getting data in and enriching it, being able to detect it, having that incident response functionality, and then proactively hunting as well. This is something you can probably, if you choose to, you can do it with the Elastic Stack. All right, let's go into a demo. Now, okay, thank you. My browser is really slow today. Obviously, when I give a demo, it's slow. But I'll start off with, I'll just head into our Kibana instance here. So for those of you who have never seen Elastic or Kibana or Elastic Security, this is basically what it is. Whereas you have an interface here where you go in,
I can only see your slides still.
Should we give it some time? Let's give it some time.
Still does the slides.
I'll stop the sharing and share again.
All right.
Oh wow, that's interesting because looks like my whole streaming session crashed. I may need to refresh, so you might lose me for a second. I'll be right back.
Yeah, we can see the video stream of you, so that's
I've lost all like my control for Jitsi.
Cool.
let me refresh for a second.
Yeah, that's okay. Yeah, so and while we're waiting for James, I want to remind you that you can ask comments in the YouTube chat, and we will have James talking about the license fuzz later on. So you don't have to ask questions about that. You can if you want to, but I'm sure that he has planned on talking about that no matter what. I hope he gets back soon, though.
Okay, hopefully I'm back.
Yep, you're back now.
All right, perfect. I will share my screen again. I have no idea. And Chrome crashed entirely, so
yeah, computers always crash.
All right, can you see again?
Yep, and at this time we can see Kibana, so that's great.
Oh, perfect. All right. Okay, so basically what I was saying is if you've never seen Kibana before, this is what it looks like. This is the latest version as of today, so 7.11. And you basically have a few different options inside of Kibana, depending on what you're going to do with the data, right? So obviously we're going to focus mostly on security here, but you can use anything, right? So everything you're seeing here is included as part of what you get. You don't just get security. If you want to use observability, if you wanted to create custom dashboards or whatever you want, this is all possible. I just want to highlight that, like, you're not restricted to anything. You can build any custom thing that you want. So I just wanted to point that out. Let's look at what we have. So this is the security overview page. So as you're bringing in that normalized data, as you're working with the tool, having detections, creating incidents, it will just show up on the overview page. So this is more of a, as an analyst, I come in, I see the state of my environment through the overview. But really and truly, where the magic happens is within detections. Now, we are one of those vendors that ships with multiple detections. So like, as David was saying, they might not all be good for you. Like as of today, we ship with over 400, but we don't just enable all of them. On the contrary, we have everything off by default, so you can turn on the ones which may be relevant for you. We take a different approach because we totally believe in what David said. Is not everything applies to everyone. Far from it. If we have a rule which says, "Oh, I want to detect every single SSH connection from the internet," that's going to be extremely noisy for most people, right? Because it's just the way it is. But as an analyst, once I turned on the detections I wanted to, and these are all examples of out-of-the-box ones, I have this view that I can start working with. So we do have full integration with the MITRE ATT&CK framework. So if you prefer seeing your rules by the tactic or technique that they hit, you can do that. We also support sub-techniques, by the way. So if you are already mature and you're following MITRE ATT&CK sub-techniques, we can cater for you as well. And everything you're seeing here so far is 100% free, right? So nothing here is paid for. so far. So you can get all these detections, which are totally open. We have a full detections repository, which is open on GitHub. We actively develop over there, so we don't have like a private repo and a public one. Everything is developed in the open because we do not, again, believe in security by obscurity. And we actually have several contributions from the community, which is fantastic. Which is exactly why we did that. You'll see here some of these are double. Just to give you a bit of context, I have a Windows machine here. I'll just bring it over. Essentially, this is just a Windows Server machine, Server 2019. And I just detonated some malware. So if any of you are familiar with this is APT28 or Suffocacy, call it whatever you want. But I detonated it. I have Elastic Agent running, which is our free endpoint tool, right? But I also have things like Sysmon, which is a bit more traditional for Windows Event Collection. So Sysmon is fantastic, again, 100% free, and it really extends what you're able to detect on Windows machines. So I also do have that. So if you're looking at this detections table and saying, hey, why does James have duplicate events? It's because I just wanted to show you the difference between having our endpoint and Sysmon. We do not force you to use our tools at all. So as David was saying, there's multiple different ways of bringing data in. Syslog, Sysmon, NXlog, rsyslog, syslog-ng, whatever you want, right? We don't really care. Even if you have a competing technology, so if you have a different like EDR vendor like CrowdStrike or Carbon Black, we absolutely do not care. If you want to bring the data in and have your detections run on that, totally fine by us. We actually write connectors. We give you free connectors to bring in that sort of data as well, because we don't believe people should have just one choice for anything. Now, once I get to detection, right, there's a few ways I can start working at it. So one of our more popular ones is our timeline. And more recently, we embellished that timeline with a graphical analysis view. So this is actually working with Sysmon data. So I have here Sysmon, and you get this sort of deep level sort of process tree insight. So I had some of those detections were actually triggered by malware. So this here, that was a phishing email. So you have Outlook spawning Excel, and then it runs a bit of malware, does certutil to decode some things. So all of this data that you're seeing was actually collected by Sysmon, and we can immediately analyze it like this if we wanted to. So you can see even like things like network requests. We're doing all the normalization in the background. You want to see file creation. So when certutil runs, that's actually when it creates its malware payload, which was then generated the malware alerts. So this is one of those views. You still, of course, have the textual way of looking at things, and timeline is very intuitive because you can either type your query, or you can even do things like dragging and dropping. So like it's really nice because you can actually drag these elements into this timeline if you're not too familiar with our query language. Within the detections themselves, there's a ton of detail. So not only do we give you the detection and the detection logic, we tell you why we did it. Again, we list out the MITRE techniques and the sub techniques, and we'll link you back into the MITRE webpage. So if you did decide to use our detections, we give you all of those, all of this detail. This is built by our security research team, right? And this is the query we're looking for. This is using our event query language. And you get all this detail, which is really nice. And if you don't want this rule to run, you just turn it off. That's it. It's as easy as that. If this is not applicable for you, if you have no Microsoft Office environments, you can just turn this off. Obviously, not everyone can have eyes on screen all the time, so we do have the ability to like send external notifications. Like, why not send it to TheHive, right? So we have Nabil talking about TheHive. So I did set up a Hive instance here, and I'm sending sort of alerts from Elastic into TheHive. That's totally possible, but we have several different options for doing that as well. Just being conscious of time, so I am over 25 minutes already, but we also have things like cases, right? So as David was saying, part of the process isn't just collecting and detecting data. You need a way to have a report of what's going on. If you're going through an active incident, how are you going to keep track of that? So we have inbuilt cases. Hand on heart say, like, it's not a full end-to-end incident response tool. So, you know, hats off to Nabil, because TheHive is way more capable at this sort of stuff. But as like an initial triage place, it's really nice because you can basically link up all your searches. You can have sort of this view with markdown syntax, so you can leave screenshots and stuff. And I won't talk about this too much, but if you did have sort of like external Jiras or IBM Resilience or a commercial tool, a commercial part of this is to send it to those tools, but let's leave that out for now. But this is all included as well. So the cases with this sort of view is all there. Last thing I want to talk about is that agent I was talking about, right? So one of the things we do offer you is a free agent, which not only collects data from a host, We also can do malware prevention and detection, so file-based malware. And that is managed through a new concept we have called Fleet. So Fleet, again, it is, let me just get rid of this error here. It's 100% free, right? So you basically have agents running on hosts. Those agents have a policy with different collections. So here, for example, I'm running Elastic Endpoint, and I'm running a system. So I'm collecting my system level metrics, so things like CPU and stuff like that. This works across all operating systems, and you can manage it all centrally. And you can also update the binaries. So, for example, right here, I haven't updated this one yet. I can actually just go ahead and update from here. So, if any of you are familiar with things like beats, this is the way forward, right? We completely different, revamped experience, much easier. And even things like the actual endpoint security policy, you can change that on the fly, right? So, if you wanted to turn on malware detection or prevention, you do it from here. If you wanted to stop collecting things like your registry events, you can do it right from in here. So this is all sort of what you get as one of the ways to bring data in. But again, you have several different choices. So let's do a demo. I'm just going to
Can I ask a quick question about the endpoint?
Absolutely.
How much do you get for free in the endpoint? How much of the malware detection do you actually get?
So the malware detection is all free. What you won't get for free is this custom notification. So this is the only paid part so far. Everything else is free, literally.
Okay. Cool.
And this is the same. Just a bit of history here. We had joined forces with a company called Endgame, which was a full-blown EDR platform. This is the same malware detection. So it is signatureless. It runs off of something we call malware score, which is a statistical model of malware features. It is on VirusTotal. So if you upload a sample to VirusTotal, Elastic is an engine on there, and that is the same malware score. So it is not a watered down version. It is the fully fledged version for free. And I'm going to end there for my demo, just because I'm being conscious of time and I want to give Nabil his full talk. But just a few more things, and I'll close off with this. Is if you liked what you saw, and you want to get more info, first of all, we have a totally open demo instance of Elastic that you can just go. So demo.elastic.co. There's most of the data and the features there that you can just try. If you want to try Elastic but you don't have time to deploy it and whatever, you get 100% free trial on Elastic Cloud. No commitment whatsoever, no credit card needed. You just go and try it. It's free for 14 days. If you want more questions, we have a totally open Slack workspace. There's thousands of people on there. So I'm there all the time, David can tell you. But David's on there. A few others are on there. So you can go ahead and ask questions about anything, literally anything. The detection repository, again, it's fully open. So it's on GitHub, github.com/elastic-detection rules. So you can see all the rules, our security research team as they publish them. We even have a full end-to-end testing framework. So David kept saying how important it is to make sure everything works and everything's continuously tested. So you can build a full CI/CD pipeline for this if you want. We give you all those tests included. So it's all there. It's all Python-based, very easy to run. That's it. So I will take any questions. Hopefully, I know it was a lot to take in, but hopefully you got a good gist of it. And I'm sorry for the interruption with my sharing.
That's okay. It went fine. We haven't had many questions, but there is one thing we need to talk about, right? Mm-hmm. The elephant in the room.
I'll let you bring it up, and then I'll talk about it.
No, but I mean all the license first. I mean, obviously you're not going to say that it's a bad thing, but can you please elaborate about what it means to the average user?
Yeah, so that's a good point, Klaus. For 99% of our users, it's not going to make a difference to you whatsoever. If you don't have Elastic as a managed service, so if you don't provide Kibana or Elasticsearch to someone and they're paying you money for it, this doesn't count for you. This change has no difference to your life at all. If you run it in an enterprise, if you run it at home, if you're using it in any sort of scenario, the license change makes no difference to you whatsoever. You can keep using it as you are using it. Yeah. Even for tools like TheHive, it doesn't make a difference because...
But I mean, what if you're an open source purist? Will it make a difference then?
If you firmly believe that everything should be Apache 2 licensed, then you might get offended about it. That's completely your thing. And we know there are people who feel that way.
Yeah.
so that's it. Like, it is what it is. I hope people realize why we did this. We didn't do this to piss the open source business off or anything. So I should say open source community off or anything. We did it to stop bullies like Amazon, because they don't only do it to us. Like, they did it to many different organizations, and we don't think it's right. If you're going to be doing that at that scale and offering the service that you did, you should contribute more, and we felt that it wasn't right. So that's the main reason why we did it. Obviously, there's collateral to people to doing that, but hopefully for the average user, it shouldn't make a difference to you at all.
All right, thanks. Yeah, as I said, we don't have any more questions. So if you do have questions, it's now or never. Yeah, but it sounds really great. I am a little bit of an Elastic user at home, but I'm trying to see how it all works, and I'm learning every day.
Perfect. Glad to hear it. All right. Well, if there are no questions, thank you again for the opportunity to speak.
Yeah,
I'll hand it over to Nabil.
All right.
And thanks again.
Thank you. Oh.
So this is me. Share. Do you see my screen?
Yeah, we see it.
Okay, perfect. So thanks, guys, for having me, for inviting me to this, I'll say, meetup. Very interesting talks before me, so I'll try to make, I will say, presentation with the same level as the two before me. So my name is Nabil Adwani. I'm co-founder of the TheHive project and a company called StrangeBee that we co-founded with two other members of the TheHive project to sustain the project. I don't have any slide to present myself, but let me do it directly live. So I'm born in Tunisia and living currently in France. Tunisia is a small country in North Africa. I'm a software engineer by training, and I'm writing code during the last 15 years now. And I started, I would say, my experience in cybersecurity space with Qualys as a developer on the web application scanning solutions. So the goal of this presentation is to present the story and the purpose of the TheHive project, giving some overview on the major products we have, and make a blink or a wink to the SIEMs, because we are talking also about SIEMs today. And the TheHive is hugely used with SIEMs. And I will explain also how you can use the TheHive and Cortex during an incident response process. And I will showcase before the end some features that are brought by the new version of the TheHive. So the story started, I will say, in 2014 at a national institution, financial institution in France, where a team had to deal with a huge number of security events with a growing complexity and with some constraints like talent shortage, limited money and time. And we were, I will say, making our incident response using some Excel spreadsheet and OneNote files. So it was not optimal. And in 2014, there were no big tools, I would say, that that help, I would say, CERT teams to apply some incident response processes. Probably there were IBM Resilient, which at that time was not really so agile for us.
Nabil, could I interrupt you a little bit? Please turn off your camera, because your slides are so pixelated, they're really, really hard to read.
Okay.
Hopefully that will improve the. Yeah, that's much better. Thanks.
Perfect. Okay. So the alternatives in 2014 to make some, I would say, to improve, automate, and collaborate during some incident response were not really, I would say, many. And the team decided to create a new project that allows automation and collaboration. And we were really closely to the MISP guys. So we discussed together and tried to bring something that worked with MISP to allow our team to collaborate with peers that work in the same industry. So we were a bank, and we know that we have, I would say, private circles with other banks that are probably facing the same threats. And the idea was, if my partner, I would say, is targeted by an attack, and if he shares with me the information, probably I'm able to protect myself really easily and very early. So that was the idea behind creating TheHive and Cortex and the built-in integration with MISP. So in the TheHive project today, we have two main products. The first one is called TheHive, which is the security incident platform. We can call it also a case management platform. And the second one is called Cortex, which is an observable analysis and active response platform. And from the beginning, in 2014, when we started the specification of TheHive, before making it an open source project in 2016, TheHive and Cortex were just a standalone application, a single one. And after that, we thought about why not split this product into two to allow other tools, third-party tools, to rely on Cortex as an enrichment platform. So that's why we see, for example, MISP using directly Cortex and the power of all the analyzers to enrich alerts. And we are also aware of other tools of the market that don't use TheHive, but use Cortex as analysis engine. Okay, so it was a good choice at that moment. In the end of 2018, we created StrangeBee because we were facing a growing number of demand from companies asking for professional support, because the project was really adopted hugely worldwide by all types of organizations, public and private, etc. So we decided to bring some sustainability to the project by selling support services, training, and things like that. And we have some plans for this year. So in the upcoming few weeks, I will say we will announce some cool stuff for our community. And in 2000, I would say, in 2020, we created a new version of TheHive, which is a complete rewrite of TheHive, because I would say the old technical stack was not really, I will say, compliant with what we had as plans for TheHive, because we wanted to introduce some multi-tenancy support, some role-based access control, and the data model we have in the old TheHive version that used Elasticsearch as a backend was not really optimal. So we moved into a new architecture based on a database designed as a graph, where I will say observable data is unique and shared between cases and alerts and things like that. And we released the TheHive 4 stable version in July 2020. And for now, we have almost, I would say, a library of analyzers and responders within Cortex with more than 160 connectors. So what's TheHive? TheHive is a tool that allows to organize and structure incidents, including technical artifacts. By artifacts, we mean observables, IPs, domain names, URLs, malware files, etc. And you have the ability to create your own observable types. Like, for example, if you have a team that handles fraud and you need to deal with data like credit card numbers, then you can create a new type and start populating your database with credit card numbers as observables. And probably you have some services that analyzes or enriches data of type credit numbers. And this is where you can create a dedicated analyzers for this type of observable. We also aggregate and collect and triage alerts. We manage cases and tasks by allowing for teams to define their playbooks or case templates that describe what are the steps that an analyst needs to follow to complete a task of specific type. We can, for example, have case templates for to handle DLPs, or case templates to handle malware infection or email phishing, etc. You can also enrich your IOCs and observable, and also take care of information classification levels like TLP and PAP. TLP stands for Traffic Light Protocol, that defines 4 levels of, I will say, how confidential is the information, if you can share it or not. And PAP is the permissible action protocol, which is a protocol that defines your posture. Can you share this data? Because probably you don't have to, otherwise the attacker will know that you are aware of his attack. And so for example, if you have an observable or a case of with a PAP of PAP red, then you cannot just send your observables, for example, to VirusTotal, because the attacker can see that the hash that he created for you is on VirusTotal. That means that you are aware of his hash, so he stops his attack, for example. So this is very important, and we don't see it always in security tools like the source that just automate things, etc. They don't deal with this type of classification levels. TheHive is also a collaborative and multi-tenant platform, in a way that you can define many organizations, and you can share cases between organizations so that they can collaborate on a single case. There is a built-in integration with Cortex for analysis and active response, and another built-in integration with MISP. Okay. And what's Cortex? Cortex, as I said, is a simple platform, simple application that has 2 libraries, a library of what we call analyzers and a library of what we call responders. I will define both concepts in a couple next slides. The goal of Cortex is to analyze observables from TheHive or from any other application, because Cortex exposes simple APIs that allows you to analyze this hash through the VirusTotal get report analyzer, for example, or search for this IP in Showdown, or ask domain tools for the whois information or the history of something, etc. And you can also, from Cortex, run responders like please block that IP, or please add this domain name to your detection rule, or please send an email to the user that reported a phishing email, or create a Jira ticket from your incident, etc. Okay. The same thing, Cortex also deals with TLP and PAP to protect your data. So you configure TLP and PLP load levels at each analyzer level, so that the analyzer will refuse any observable that violates these constraints. Cortex also handles some caching of reports and jobs, secure your rate limiting, and also allows multi-tenant usage. So let's define some words that we are using, like feeders, analyzers, and responders. So feeders are programs that gather information from external services into the Hive as alerts. So when you start using the Hive, you need to populate it with alerts, and probably SIEMs are a source of alerts. EDRs, CTI providers, etc. Any tool that belongs to your detection infrastructure is a potential source of information for the Hive. So you detect, and using the Hive, you make your response, your investigation. And that investigation can rely on other tools like SIEMs. For example, you have an IP, you want to see if that IP has a hit in your SIEM, or you have a malware file. You want to see in your logs if someone started or launched that file, or is there any execution, or is there any download of that file name, etc. So feeders are the scripts or the middlewares or the connectors that bring alerts into the Hive. And they rely on the Hive APIs to just create a new alerts that can include observables, that can include tags, that can include description as markdown content, so on and so forth. So here, for example, this is a feeder that from an email gather reports of suspicious messages received by internal users and generate alerts. And alerts includes all the significant data that we can parse from an email file, like the sender, the destination. Are there any attachment files? So get the attachment files and include them as observable file observables. Probably you can tag them because you have some details you can parse during the before creating the alert. And so yes. Now let's talk about analyzers. Analyzers are one of what we call workers or neurons in Cortex. So analyzers have the simple role of analyzing an observable. So as an input, you have an observable, and as an output, you have a report. And the report will contain two things. What we call summary, which is a set of taxonomies describing some details like virus total, get report found 20. That means that there are probably 20 files on virus total talking about 20 file submissions of the same hash, or probably you ask for maxmind to make the geolocation of an IP. You will get a summary report that tells you what's the country, what's the region, etc. Okay, and the second part of the output of an analyzer is the long report that contains everything, the raw data of the analysis. And the third party is a list of observables. The list of observables is used by the Hive to propose to the analyst to import the new discovered observables by the analyzer. So probably you have a URL or you have a file, you analyze it using a static analyzer, and you will probably discover some interesting strings in it. You will probably describe some URLs of a download of C2, for example. And it's important that the analyzer extracts all this meaningful information and propose them to add to the analyst so he can add them to the case. Here's, for example, a report from VirusTotal because the Hive allows you also to define visual templates that display in a human readable manner the raw reports that the analyzers return. And the third part is the responder. The responder is, I will say, the same type of connector as analyzers, but their goal is to act and make action on a third-party tool. Like, for example, please create a ticket in Jira, or please add an observable to a blacklist, or please add this URL to a whitelist or a blacklist of a gateway or something like this. Or, for example, just disconnect a machine, disconnect an endpoint. And responders can be applied or act on any type of data in the Hive, like alerts, case, tasks, task logs, and observables. Not just on observables, but in any type of data in the Hive. And the result has a status, success or failure, and a set of operations that the Hive understands. And for example, a type of operation could be, please, the Hive, add this tag to that case or to that observable, or please add or close a task or add a task log or something like this. So the goal is, from the Hive, you call a responder that acts on an external system and returns something to apply to the Hive. What will be a typical, now that we understand all the concepts, what will be the typical integration? So what we see today is that the Hive is mainly used with MISP, Cortex, and and tools that detect and create alerts in the Hive. So we can see, for example, feeders that create alerts from email reporting, or from SIEM, or from CTI providers, or any other custom field. It may be some detection platform homemade in your company, or a legacy system that can generate some alerts. So everything, all the alerts come into the Hive. The analysts need to make the triage and decide which alerts deserve an investigation and which one deserve just to be ignored because they are not applicable, or we know that they are not malicious because we did probably a analysis before creating the alert, or something like this. And using Cortex, you can call any type of service, like, for example, IP reputation, sandboxing, for example, Showdown to get some information about an IP or a certificate. You can also use probably private CMDBs or asset management tools, so on and so forth. And the other part is the responder stuff, which is sending emails, creating ticketing system, tickets in ticketing system, or probably add some detection rules in some detection tools. And if you have some, I will say, private or public MISP circles with which you can share your discovery and your analysis, where you can share your IOCs, for example, then you can by one click from a case decide which I would say MISP you want to share the case with, and this brings all the case from the Hive with its data and its IOCs, and create an extended event in MISP that you can review and apply to an existing case, to existing event. And of course, the Hive can be connected to multiple MISP servers. Some of them can be just for import only, and other can be for import-export. So these are some slides I added for this presentation, which focuses on the relation of the Hive and SIEM. A few months ago, we have asked our community about their usage with a survey about their usage of the Hive, and 64% of them responded with, yes, we use the Hive with the SIEM. And this information, we know it because we have many, I would say, customers and users that ask us or tell us their story about how they use the Hive. And what we see is that the Hive is used most usually with Splunk, with the Elastic Stack, with QRadar, with Traylog, with Logpoint, and with ArcSight. And there are also other integrations, but I would say they are minor. Probably NetWitness from RSA, or and other tools. Now let's focus on the Hive and the Elastic Stack. So the Hive 3 and Cortex are using Elasticsearch today as a database. And ELK, Elastic Logstash and Kibana, is the most used SIEM with the Hive. And I will show you why. Thanks, by the way, to Yelp for the ElastAlert and their Hive connector. I don't like this name, but I will say it's not easy to update all the configuration files of the ElastAlert that are talking about the Hive. And also there is also another integration that can be done through Watcher, which is part of XPack. And probably in the future, we will see another solution like this one that James showcased a little bit earlier. But I think that today we can make this happen with the webhook option, but we will try to work with Elastic and reach out to them to think about adding this option by default built-in in Elastic to support the Hive notifications. We also have a Cortex analyzer that allows analysts to search some observables in Elasticsearch, And this has been contributed by Nick Prokop and Nick Penning from South Dakota. They are early adopters of TheHive and users of Elastic also, so very good contribution. In the wild, you can see some blog posts talking about this is how you can make a SERP based on some open source tools, and we always see that TheHive and Cortex are used in a bundle with Elasticsearch, Logstash, Kibana, ElastAlert, and tools like this. For example, here, which is a blog post about SOC as a service, which is a very good article. Here's another tool called Sister Toolkit. So here's a slide with some links, so you can see them. I will share the slides, so you have access to the blog posts. And there are also some other bundles like Security Onion, Sister Kit, and another new one made by an MSSP in India that is called Invincence, that includes TheHive, Cortex, Shuffle for Soaring, and ELK. So how you can use TheHive as an incident response tool? I would say this is the six steps incident response process defined by SANS, that contains preparation, detection, identification, containment, eradication, recovery, and lessons learned. And TheHive and Cortex can cover all these steps. For example, during the preparation, you can prepare your custom fields, you can prepare your dashboards and your case templates. For the detection and identification, you can rely on the Cortex analyzers to enrich your observables. And during the three other steps, you can rely on responders, probably to contain some infection, blocking some machine or some IPs. Same thing for eradication and recovery by sending some emails, communicate with users, etc. And the lessons learned can be applied in TheHive by writing some, I would say, investigation summaries in some lessons learned tasks, where analysts can, I will say, write up all the discoveries and all the lessons learned during the investigations. Let's talk about the features of TheHive 4. I'm assuming, I will say, I'm not going to talk about the basic features of TheHive. I'm just showcasing some new features. I would say as I said earlier, the main news from TheHive 4 is multi-tenancy and role-based access control, because TheHive 3 was not MSSP compliant. It was flat. It was made for flat teams, so everybody can see everything and everybody can do anything. So the idea of TheHive 4 was to create the possibility to define in one instance of TheHive many organizations that can be isolated or collaborate on some specific cases or some specific tasks of specific cases. So we created a concept called the sharing, which allows a team or someone to share a case and decide what are the parts of a case to share with one or several organizations. We introduced also some UI improvements. We introduced the TheHive, which is a very cool feature, two-factor authentication and improved OAuth support. So from an architecture perspective, TheHive has the same front-end architecture, and it relies on another, I will say, core framework that we created, which called Calligraph. And our data model is using Janus Graph, which is a graph database that stores its data in many engines. And for now, we support Cassandra. And we also use Hadoop or MinIO for file storage, files like the observable files and the task log attachments. So let's go quickly through the features. So notion of organization. In TheHive 4, you have a super admin that is able just to make administration actions like creating organization and linking them together. An organization can have many users. A user can belong to many organizations, and a user can switch from workspaces from organization A to organization B and see different cases and different alerts. Alerts can be, cases can be linked together, so they can, I will say, see the data of the other organization when sharing happened. Okay. We introduced also the concept of permissions and profiles. A profile is a set of permission, and TheHive will rely on the permissions of a profile to allow or disallow a user from doing a specific action. For example, a user that don't have the ability to create tasks won't be able to do it, neither from the UI nor from the API. So this is what we call rule-based access control. The concept of sharing is simple. I make an object I own visible by an organization I trust. So if I want a team to work with me from another organization on a specific case or complex case, then I just have to share that case with them, and they can see the case in their list of cases with the flags that I shared the case with them, and with the flag that tells how many organizations have access to that case. So it requires a specific permission to be able to make some sharing, for example, which is called manage shared permission. And the sharing applies to cases, tasks, and observables. So you can share, for example, a case without sharing all the TLP read observables. And this becomes in the UI as a new button called sharing. Opens a new dialog that allows you to select the organization with which you want to share the case and select some options for the sharing. The UI improvements we introduced in TheHive for also, for example, the UI is now RBAC adaptative. This means that if you don't have a permission to do something, that we don't show you the action that allows you to do that. For example, if you are not able to create, you don't have the permission to create cases, then the UI won't show you the create case button. And this applies everywhere in the app. If you cannot analyze observables, that you won't have the action that allows you to analyze observables. We enhanced also the alert triage by reviewing, I would say, the whole section for performance reason and for feature reason. For example, we introduced the flag called ignore similarity that can be applied to an observable, and when set to true, that observable is not used in any similarity compute. For example, you won't ever have any similarity based on this hello.txt file because we flagged as ignore similarity. We also reviewed the section that displays the similar cases of an alert by adding some features like filtering, selecting what type of observable has matched, and also some filters on the rates of similar observable and similar ICs. We also updated the filtering capabilities in all the UIs to allow operators, or for example, in tags filter, or any other, I will say, enumerated value. This allows you also to filter by custom fields. It supports wildcard and many features like this. Some of you that know TheHive probably see that tags are not displayed the same as before. We support now the colors of the tags because this is a screenshot coming from my development station that includes the taxonomy support, white attack support, and stuff like this. So typically in alert lists and case lists, you will now be able to quickly filter your data using the custom fields you have. Today, we believe that our users probably use tags wrongly because they put data that don't have to be set as tags, but as custom fields. And the problem is coming from the fact that TheHive currently does not allow filtering data by custom fields very quickly. So people put data in tags because tags have quick filters. So to resolve this issue, we now allow displaying custom fields in lists, and by simple click, filters can be listed quickly. We also added bulk actions in different lists cases like observables and alerts. Some visual statistics in case alert and observable lists, and also the Hive FS. So the Hive FS stands for the Hive file system. Basically, it allows you to connect a WebDAV client to have access to your TheHive as a file system. That contains your direct access through an explorer to your file observables and to your attachments in task logs that can be screenshots, memory dumps, or things like that. So this can allow analysts to quickly and easily play with the files. Just pay attention, they are not protected in there, because the old version of that allows you to access to your, for example, file observable, where to go to the UI, download the file as a zip with the password, type the password, and you have access to your file. Now you can connect to the Hive as an explorer, and you will see the list of your cases by number, a folder for each case, and in each folder you will see observables and tasks, and in there you will have your files, and you can connect from an analyst machine and play directly with your malwares. We now allow also the 2FA authentication. So administrators can see the users who activated the option. Well, today we cannot yet force the users to enable 2FA, but you can probably monitor the users who did not activate the option and probably notify them by email or lock them down, or I don't know. We also improved the single sign-on options and tested compatibility with Okta, Microsoft 365, Keycloak, Vision Auth, Google, OpenID, etc. So that's all I have for today. I hope it was not so long. So if you need help, once again, there is a company called StrangeBee that you can reach out. You can reach out to and ask for anything you need. Otherwise, you have the community. There is the Discord channel and the blog, the Twitter, and the user forum. Just feel free to ask questions, guys.
Thanks a lot for the overview. It's I didn't know TheHive very well before, so there was a lot to take in, that's for sure. But I do have a question about yourself and your engagement in TheHive. I mean, what was it that made you interested in it to begin with, and what is it about it that fascinates you so much, and that you want to spend so much time on it? Could you talk a little bit about that?
Yes, of course. So when I joined the team that started this project, I was a developer on TheHive, and I would say I was committed and engaged to make it a great tool for that team. And after 2 years of work, we sat down and discussed, hey guys, why don't share this work with people that we trust, and with people that might have the same issue with as us? And we are using MISP, so MISP is open source. Let's do the same and share back to the community that produces open source tools. And that's why we decided in 2016 to make it. I was working. I'm still working for the company who is, I would say, where TheHive started. So, and also I'm working for StrangeBee, which is a company that I would say I co-founded with two other people from two other co-founders of TheHive. And today, StrangeBee is the only, I would say, company that is governing the TheHive project. We don't have a lot of contributions in TheHive itself. We have many contributions on the Cortex analyzer side, Cortex responder side, but TheHive and Cortex as tools don't have many contributions as code. I mean, but we have many contributions, like people who tests who test the product, people who ask questions, submit feature requests that I'll say that improve the tool. But in the tool itself, today it's pushed by StrangeBee. StrangeBee hires people. We hire people to develop some features. The Hive 4, for example, has been, I would say, developed by people that don't belong to StrangeBee and don't belong to the Hive project, but people that we paid. This is our commitment today. We are fully engaged. And our objective is to sustain the project because it's adopted by huge companies all around the world. Many companies are making money with it. For now, it's fair, I would say, for now. Probably we will face the same issue as Elastic in the future. Most certainly, I would say.
That's a common issue, right?
It's a common issue. There are fair people, but all people are not fair. So, and we don't want to stop the project. We don't want to let down the people who trusted the project from the beginning. Our commitment is to keep the Hive project as open source. We have some idea to monetize some stuff. We will unveil that in the upcoming weeks, and it will be huge. But the Hive will be and will remain open source. So this is the main thing.
Yeah. So how do we make money of it? I mean, your original company that started the Hive. I mean, you said that they are the main contributors, but are others contributing money or development time on it as well, or how do we make your money, basically?
Well, we sell support through StrangeBee today. We have customers that have annual subscriptions. Annual support subscription. I mean, customers who think that using an open source project need probably more than the best effort from the community. They have any issue, so they have the experts of the product. They have the people that created the product to help them if they face any issue.
Yeah.
And this is how we monetize the product today.
Yeah. And also, I guess it would make sense that if you make money of any open source project, you would want to contribute to it or help it out in any way, also for your own business sake, right?
Yes.
Yep. All right. David wants to know what happened to Sad. Did he leave the team?
Well, Sad started his new, I would say, position in CertU at the end of 2018, and we took the lead. I took the lead on the project with Thomas and Jerome. And Sad, I would say, he's not very active currently on the project. So let's take it from there.
All right. That's okay.
I think that he don't have time. I think he has responsibility. He has much bigger responsibilities today, and I think he doesn't have time to work on the project as the beginning, I would say.
Okay. Life happens, right?
Oh, yeah, of course.
Yeah,
of course.
But,
that's fair. That's fair.
Yeah, but we don't have any more questions. So with that, I'll say thanks a lot for your talk, and of course also thanks a lot to the other people, to the other guys, David and James, who also talked here today and decided to spend some time with us.
Thank you, guys. Thank you.
Yeah. All right. So yeah, I guess that's it. All right. Okay, are you cutting the stream or?